Okay, hello to everyone. Um, I want us to try this example on how to determine if a given function is a solution of a differential equation. I want us to try this last example before we move to our next subject. So we are to show that y equal to 1 over x squared minus 1 is a solution of y prime plus 2x y squared equal to 0. So all we have to do is the first thing we have to do is to know that we have y prime and our function is in y. So we have to find the derivative of y, the first derivative of y, in order to be able to substitute it into our given differential equation here. So let me scroll up. So you can agree with me that if I write y equal to 1 over x squared minus 1, it is the same as x squared minus 1 over negative 1. And this will make it easier for us to differentiate. So in doing so, our y prime is going to end up to be negative 1 times x squared minus 1. And this is actually what we call the chain rule. This is what we call the chain rule. And we are now going to differentiate the inner side, which is just going to be it's just going to be 2x. So as we brought the negative 1, we have to subtract 1 here, which we got negative 2. So writing it back in its original form, we are going to have y prime to be equal to negative 2x over, because it is raised to the negative, it has to be a denominator. So we have x squared minus 1 square. Okay. And now, since we know our equation and we now have our y prime, let's try to substitute it into our differential equation here. So let me memorize it. Y prime. Let me memorize it. So we have y prime. I think it was plus 2xy squared. And we know y prime to be negative 2x over x squared minus 1 square. And we have 2x. I'm going to substitute the value of y into the equation. And from our the beginning, we know y to be 1 over x squared minus 1. But it is squared now. And we have to ensure that this must be equal to 0 in order for our y to be a solution. So let's see whether it fulfills that term. So writing it in another form, we can see that here becomes 1 square, here becomes x squared minus 1 square. And we are multiplying by 2x. So we have negative 2x over x squared minus 1 all square plus 2x over x squared minus 1 all squared. So we can definitely see that this side is similar to this side, just that one is negative and one is positive. So in so doing, this cancels this, and we can now see that it evaluates to 0. So that's how we can therefore say that our y equal to 1 over x squared minus 1 is a solution of our differential equation. Thank you all. I'll see you in our next class.